Welcome to our training and guideline session on the basics of rules within our platform. My name is Gijs Gijvels and I will be your host today. Let's get started. The topics I will be covering today include the basic concept of rules, the principles of rules, basic rule notes, and guidelines in order to make your work readable and transferable. So, to start off with, what exactly are rules? Also referred to as business rules. The Expivi rule system allows you to manipulate attributes, material groups, and showcase entities by checking certain conditions within the product configuration. As you can see from the sample images below, working with rules is a visual programming tool within the backend. By connecting specific rule nodes, you will be able to manipulate a product configurator. The concept of rules is to generate a signal based on an action. This signal can, for example, be generated by changing an option, a material, or clicking through the configuration steps. After the signal has been generated, it will pass through all connected paths. Once it arrives at the next rule node, it will check the rule's condition or perform its actions. I will be covering the basic rule nodes one by one, but first you should understand the core logic of the rules. On to the principles of rules. In order to better understand the rule system, I will be covering the different types of rule nodes, the input and output of rules, the difference between check and active, and lastly, the variation of conditions belonging to rule nodes. In total, there are 4 types of different rule nodes: broadcasts, checks, actions, and utilities. Broadcasts are the starting point of every rule set. This node generates a signal when an event has taken place in the configurator. By selecting the appropriate broadcast node, you will be able to control the rule set only if a particular event has taken place. Let's say you only want to send out a signal if the web page is loaded or refreshed. You will be able to do so using a scene initialization broadcast node. Broadcasts can trigger off of events created by their own rule set. It is common for a rule set to be executed multiple times until all actions have been resolved. Selecting an option that is already active does not actually change the state of the question and will not trigger the broadcast again. Check nodes are used to check the condition of an attribute, material group, or showcase entity. Using these rule nodes, you will be able to specify which signals will proceed through which outputs. Using action nodes, you will be able to define an action to be performed within the product configurator. This can range from selecting options, changing material colors, adjusting camera positions, and much more. In regards to utility nodes, for the purpose of this session, I will only be covering the timeout rule node. This node makes it possible to set out a timeout in order to hold on a signal for a defined amount of time. This means that you will be able to create a delay between broadcasts, checks, and actions. Let's talk about the inputs and outputs of rule nodes. As you can see from the image below, rule nodes always have input and output points. Broadcast nodes only have outputs, checks have both inputs and outputs, and actions only have inputs. When connecting an output to an input, it allows a signal to move from one node to the other. As you may already have figured out, you will only be able to connect outputs to inputs. Some nodes have 2 output points. As you can see from the image below, the upper output point will be used when the conditions checked within the rule node are true, and the bottom output will be used when the conditions checked within the rule node are false. This next topic will cover a very important difference between checks and actives within the checks rule node types. Shown in the example below, you see 2 nodes that are used to check the condition of a selected option. However, the method of checking the conditions between these nodes is very different. The check option node only passes on the incoming signal if the specified attribute condition was responsible for generating the signal in the broadcast node. This type of check allows you to perform an action that isn't necessarily always true, but only after that specific event in the configurator has taken place. The active method checks if the condition is active at the moment the signal comes in, meaning it will take a look at the condition defined within the rule and see if that condition is being or already selected at that time. In contrast to the check option node, this node will always check if the specified condition is true, regardless of which event created the option changed broadcast signal. It is very important to understand the fundamental difference between these two methods, as both can offer a unique outcome. Next up, rule node conditions. Some rule nodes have an additional option to define in which way the condition is being checked, or the action is being executed. These two can be found under either apply on if we're talking about action type nodes, or condition if we're talking about check type nodes. Within visibility nodes, there are three options on how to execute the actions defined within the node. In visibility nodes, checking a box means that the specified option, question, or material should be hidden, while an unchecked box means it should be visible. Apply on all means that all visible actions, checked and unchecked boxes will be executed. Apply on only visible will ignore any checked boxes and show the items that have been unchecked. Apply on only hidden will ignore any unchecked boxes and hide all items that have been checked. Because the only hidden and only visible conditions only set their own visibility state, these modes can be used alongside other visibility nodes without having the full override effect of the apply on all condition. Within some of the check type nodes, you will be able to define how the check will be performed. When selecting any, the node will look at the different checks that have been defined, and if one of these checks meet the condition, the true output will be used. If all is selected, the true output will only be used when all conditions within the rule node are met. None works in opposition to all. If no options that are being defined are true, the true output will be used. Selecting none is virtually the same thing as using the no output. For legibility reasons, it is usually clearer to use the no output with the any condition instead of using the none condition. Now let's cover the basic rule nodes. The option broadcast generates a signal if any option is changed. If an option is set to the value or state it already is, the option broadcast will not generate a signal. The question broadcast generates a signal whenever a drop-down menu is opened without actually selecting something, or by clicking on a step. This broadcast is usually used to change cameras, since it indicates that the user is engaging with a particular question, but nothing was actually changed configuration-wise. The material group changed broadcast generates a signal whenever a material is changed. This can be either through the user clicking a material as a configuration option, or as a result of a rule selecting a material. Contrary to an option broadcast, selecting a material that was already selected will generate a signal in the mat group broadcast. This means that it is a lot easier to create infinite loops with this broadcast, which will result in a frozen configuration viewer. The input broadcast generates a signal whenever a user interacts with an input field, such as operable number inputs or text to image. The scene initialization broadcast generates a signal whenever the page is loaded for the first time. This can be used to set complex default states, but it can be somewhat unpredictable since the technical state of initialization is not always what you should expect. Preferably, default values for attributes should be set within the attribute list of the product. The forward node. This node doesn't actually fit the description of a check node and does not add any functionality, but it is an invaluable tool for organizing the node layout. The forward node takes any signal and simply passes it on. It can merge different inputs so that the nodes in the rule set can be reused. The changed option node. When the check option node receives a signal, it checks if the specified option was the cause of the signal. This is useful for very deliberate choices that don't need to have a continuous effect. For example, choosing a desk width of 1 meter should also automatically select a privacy screen of 1 meter wide, more like a suggestion. After the screen has been forcibly changed to a meter width, the user can still change it back if they prefer something else. When using the active option check, it would force the width change every time an option changes, effectively removing any choice for the screen. Changed question node. This node should only be used in conjunction with the question change broadcast node. It checks if the specified question is the cause of the signal from the broadcast node. Check material ref node. This node checks if the specified material change is the cause of the signal from the broadcast node. The check matref node can only be used when using a material group broadcast node. The check input node. This node checks if the specified input was responsible for generating a signal in the broadcast. The active option node will check the state of the specified option every time a signal is received. Because this node tests the specified option every time a signal is received, it becomes a very powerful logic tool. So as you can imagine, if a certain option is being changed, if a certain condition is true, then a certain action must be executed. Active material. This node checks if the specified material is currently active. The active matref node should primarily be used in combination with the option change broadcast node, since it can be easily create infinite loops with the material change broadcast. And lastly, the active camera. This node checks if the specified camera is currently active. This is often used to check if a camera that you want to switch to is already active, so that you don't accidentally go back into the initial position. Let's talk about actions. First off, the select option node. This node is used to select options within question attributes. The select color node. This node selects an option within a color attribute. The select camera node can select a camera predefined within the showcase. The offset node can translate predefined offset groups. The position of the offset group will be set to the value that is being specified. If you want to translate among multiple axes independently, you will have to give each translation its own level. For example, increasing a table's width requires an offset of the legs along the x-axis. Increasing the table's depth requires an offset along the z-axis. This is done through two different offset nodes. The first offset group will have a level of 0, as you can see over here, and a value of 0.5 within the x-axis. The second offset node will have a level of 1 and a value of 0.5 within the z-axis. The values of the different levels are combined to create the final position. The rotate offset node. This node allows the rotation of an offset group. The desired pivot point on the model should be moved to the origin 0.0.0 within the scene of your 3D file. The object should have its transforms values frozen, resetted, or locked, depending on the software you're using, and then translated back into the place where it belongs within the scene. Also, an important thing to note is that we can define the amount of time it takes to reposition or to change the rotation of an offset group. We can do this by going into the offset group node, scrolling down to the bottom section, and change the speed parameter. The mat group or set material node. This node can select a specific material within a specific material group. As a side note, the material group does not need to be added to the attribute list in order to change the material option within rules. This node is not used to assign materials to meshes that are not linked to a material group. These need to still be assigned within your 3D software. Next up, the input value node. This node is used to place a value, either text or numbers, within a text to image or text input attribute. The update attribute node. This node can be used for a number of things based on the rule node that is to be updated. As an adjustment that applies to all attributes, you will be able to update the attribute name. As an example, within the text to image attributes, a number of parameters can be manipulated. These include the text outline, the text color, and the outline color. Within a text to image attribute, you will be able to control the height-width ratio of the uploaded image and assign a different material on which the uploaded image will be applied. The set color node. This node allows you to redefine a diffuse color that will replace the current color within a specified material. The set map rule node. This node can be used to override a texture slot like diffuse, normal, transparency, and so on. This can apply for either a single texture or an entire material group. Next up, the messages. Message rule nodes allow you to create a pop-up in which you will be able to define a text that will be displayed within that pop-up. You are able to choose from 3 different types of message rule nodes: alerts, warnings, and toasts. However, the difference lies within the styling of these pop-ups. It is basically the same for all 3. The hide question node. This node hides a single question within the user interface. The show question node makes it possible to show a single question within the user interface. The color visibility node. This node can control the visibility of all options within a specific color attribute. The option visibility node can control all the options within a question attribute. The question visibility node. This node can control the visibility of multiple questions at once, as opposed to the single question visibility of show and hide question. The material visibility node. This node can hide or show materials within a specified material group. Note that when a currently active material is hidden within the user interface, it is still active within the viewer. The disable option node. This node can disable options within question attributes. Contrary to hiding or showing options, this rule node can be used to gray out options that should not be available. As a side note in regards to visibility, rules can always override any default visibility settings that are defined within the attribute list. As I mentioned before, for the purpose of this video, I will only be covering the timeout rule node within the Utilities tab. This will basically allow for a delay between broadcasts, checks, and actions. The timeout rule node will allow you to hold on to a signal for a defined amount of time. Now for some guidelines. As well as the functions themselves, I will also talk about creating a rule system in a way that is readable and transferable. These include rule node naming, spacing out your rule nodes, and the size, readability, and recycling of rule nodes within your rule set. So let's start off with rule node naming. As you can see from the example below, it's very important to name your rule nodes according to the function they're representing. If you do this properly, you will be able to transfer your work or even go back into a previously created rule set much easier and much faster. You will be able to do this by going into any rule node and changing the name field. As well as naming your rule nodes accordingly, it's also very important to provide enough space in between your rule nodes. As you can see from the images below, on the left hand side we can see a very small and cramped rule set put together. It's not really readable, and if you want to make any adjustments, it might be hard because of the lack of spacing. On the right we can see the exact same rule set, only with some forwards put in between and the nodes properly spaced. This makes for a much more readable rule set. In terms of the rule set size, an average of 120 rule nodes per rule set is advised. If you exceed this number of rule nodes, you might have trouble reopening previously created rule sets. Next up, let's talk about rule set readability. As you can see from the image below, the rule set shown is not really representing a neatly created rule set. In order to avoid this kind of rule set, start using more forward events to make your rule set more readable. Again, by creating a more readable rule set, you will be able to transfer your work or revisit your previously created rule set much more efficiently. As a final topic, you should reuse your rule nodes as much as possible. In the example below, you can see on the left hand side that a rule set has been created with 3 identical broadcasts. In reality, this is not really necessary because the signal will be created either way. On the right hand side, we can see that only 1 broadcast has been created, and eventually it will branch out to the different checks and actions accordingly. By adapting this work style, you will be able to create a much smaller rule set with the same amount of functionality within. Thank you for taking the time to look at our video tutorial. I hope you learned a lot, and see you during our next session.